Hi, we're going to talk about E. E is a universal constant, second only in fame to pi. Both are irrational, their decimal expansions go on forever, and we're going to be graphing E. So let's take a look. Alright, the number E is right there above the division sign. So if you say second divide, you will come up with the letter E. And if you hit enter, you'll find that E is approximately 2.7 and then a bunch of decimals that go on forever and forever and forever. The most famous names in mathematics are attached to this letter, which is really a number. Alright, we are going to get a decimal approximation for e to the negative 3.45. So let's do that. Now, e to a power is found here above the key ln, and you're going to know what that is soon. Natural logarithm. Alright, you don't know what it is yet, but you will soon. So I'm going to say second ln. And that gives me e and a box to put an exponent in. So I'm going to use the exponent negative 3.45 and then enter. And it says here round to 4 decimal places. 1, 2, 3, 4. That 4 will not cause the 7 to go up to 8. So my decimal is going to be 0.0317. All right. Now we're going to graph. Okay, let's go to y equals and clear anything out that might be there. I'm going to say second ln, and I'm going to put a negative x in the power, negative x. And then I'm going to hit the right arrow key to bring the cursor down, and I'm going to say plus 2. Now I'm going to graph it. This was an exponential function. We really need to look at what e to the x looks like. So let's go back to y equals and hit clear and say second ln, and I'm just going to put an x up there so that I'm graphing y equals e to the x. Now the x-axis is an asymptote to y equals e to the x, and so this leg travels along the x-axis, getting ever closer and closer and closer to it for all negative infinity. Okay, so what we're graphing here is second ln e to the negative x plus 2. Oops, graph. Okay, let us, this is the only one that looks even remotely like it could be what we're looking for. So let's say B. And we're told how smart we are. No, we're not. We're just told we did good work. All right, let's graph y equals 1/5 to the x power. This is an exponential function. All right, parentheses, 1 divided by 5, parentheses closed, raised to the x. Let's graph it. Now, the x-axis is the horizontal asymptote. This is really going to be traveling along the x-axis, getting ever closer and closer and closer to the x-axis, but never quite touching it. All right, and this, I believe, is what we're looking for. Okay. 21. Sketch the graph of the following and describe how the graph can be obtained from the graph of the function 2 to the x. Well, it sounds to me, if we're going to do something like that, we'd better look at what 2 to the x looks like. Not 2x. 2 caret x. And I'm going to graph that. Looks pretty much like e to the x. Alright, this is the basic graph of y equals 2 to the x. Here we have 2 to the 2 minus x. Let's take a look at that because we're going to be translating it. 2, there we are. I'm going to say 2 minus x. Actually, I'm not. I'm going to say negative x plus 2. That's the power. It's the same thing as 2 minus x. Now I'm going to hit the right arrow key and then say plus 2. Let's graph it. All right. So I think this must be it. Now, you remember those rules of translating, right? If you have a negative in front of your x, that flips the graph sideways around the y-axis, and then a plus 2 where the x is means you're going to go 2, move the graph 2 to the left, and then a plus 2 outside of that says you're going to move the graph up 2 places. Think of this power, negative x plus 2, as being in parentheses. So we're going to take the graph of 2 to the x, flip it around the y-axis, move it to the left 2 places, because remember, we're going to go in the opposite direction from the sign. And then, this is our vertical shift, we're going to go up 2 places. So let's find something that says that. We're going to shift the graph of y equals 2 to the x, indeed, to the left 2 units. Then reflect across the x-axis? No. Reflect across the y-axis. Let's see what this says. Shift the graph of y equals 2 to the x to the left 2 units, indeed, to the left 2 units, and then reflect it across the y-axis, and then shift it down. No, it's going to shift up. So we need to find one that meets all of our specifications, and it may be C. Let's see. Shift the graph of y equals 2 to the x to the left 2 units, then reflect it across the y-axis, and then shift it up 2 units. I'm going to go for C. Yes. Okay. Now sketch the graph of the function y equals 2 to the x plus 1 minus 4. Okay, so we're still dealing with 2. So what am I doing here? I'm going to have x plus 1. Nah. that's too much trouble. Let's just clear it. All right, 2 caret x plus 1, right arrow, minus 4, graph. I believe that's it, C. Maybe not. Let us get a view here and detach. And let's look at this. That might not be it. Let's go to B. No, that's definitely not it. Let's go for C. Ah, we were right. Okay. Now that's it for that. 23. Now let's graph this, and then we're going to talk about it. Clear. It just seems easier to clear. We're going to have 3 times 2 to the x minus 1, right arrow, plus 1. Let's graph. Okay. I think this is definitely it. Okay. Now we have to say how this happened. All right. If you take y equals 2 to the x, move it to the right 1 place, move it up 1, and stretch it vertically, that's what this coding does. So let's see. Shift the graph y equals 2 to the x. To the left, oh no, to the right. So it's going to be, the answer is going to be one of these. To the right 2 units, we are going to stretch it vertically, and then we're going to shift it up. So I choose D, and there we go. So you see how all of these are done. That 1/2 is going to shrink the graph vertically. The negative e to the x is going to shift the graph upside down over the x-axis, and the 2 is going to move it up. Okay, so just remember everything you learned about translating, and I'll talk to you later.